Welcome everybody to our July meetup. This month, I'm thrilled to say that we have Danilo Poccia joining us. He's going to be speaking about the wonders of serverless. So he's from AWS. For those of you who don't know him, has spoken at many events in the past. And he's a chief evangelist there at AWS. So looking forward to that. I guess a few little housekeeping things before we kick off, though. So first off, for those of you who don't know who we are, my name's Chris. I'm part of the team that organise NETech. We also have James, Mark, and Martha. Collectively, we kind of organize events and kind of make sure that any feedback that you guys have is kind of passed on to our speakers and also to ourselves as well. If you want to get in touch with us, then there's all the social media handles. Find us on LinkedIn and Twitter, or as well as the NETech social media handles, which are, there we go. So all of the main ones. Obviously, we've got Facebook, LinkedIn, and Twitter are kind of the main ones, I guess. But we also do have a Discord channel. The easiest way is if you go to any.technology, and there's a contact us page, which you can join there. Big thanks to our sponsor. So we're sponsored by Scott Logic. So yeah, usually we have kind of, or in the past we had physical meetups. I guess without Scott Logic, we kind of wouldn't have a meetup. There was the kind of, we had free beer and pizzas for everybody to kind of go along with the speaking and talks. But you know, obviously hashtag COVID, we've kind of moved to a virtual setup now. But you know, we still managed to kind of bring all the best speakers. And yeah, I'm thrilled to bring you Danilo today. But before we kind of kick off, I want to just you know, highlight one thing. So it is actually our 2-year anniversary. So yeah, we started 2 years from today. With just a little meetup in the Everyman Cinema, funny enough. That was July 2019, so there's a picture from back when we were doing talks there. Very quickly, though, we kind of discovered that we needed a bigger venue. So come October, we moved to a place called the Control Pad. Yeah, I guess for those of you maybe not in Newcastle, the Control Pad, it's a place where there's like a bunch of video games and TVs and computers and you know, the full works, and it's a really interesting venue. You know, if you're a gaming fan at all, or even just any general tech fan, you know, it's a fun place to be. Some retro gaming there as well. If you're a fan of like the SNES and all that, great. Yeah, and then now, kind of fast forward to today, we have 924 members. So I updated this not maybe 20 minutes ago. So we're nearing 1,000 members, which you know, is going to be a great milestone for us. So it's full steam ahead from here. We've also I've been talking about this for a few meetups now, which I'm sure some of you are aware. But yeah, we've also finally released our YouTube channel. So if you search for any technology, again, though, if you kind of go to our contact us page on the website, then there's a link there that you can get to that page. The recording from this meetup and all of our other meetups as well will shortly be on that YouTube channel. Although, as I've discovered, when you upload things to YouTube, it seems to take forever when you upload an hour-and-a-half video. Processing on the YouTube side seems to take a while. But yeah, keep an eye out on there, and yeah, you can find out all of our meetups on there. So, kind of moving on to our speaker for this evening. So as I said, we've got Danilo Poccia, who's chief evangelist at AWS, and he's going to be speaking about what we can do with serverless in 2021. If you want to get in touch with them, he's pretty much Danilo P over pretty much every social media platform, as far as I'm aware. Yeah, so without further ado, I guess I will hand the stage over to yourself, Danilo.
Thank you, Chris, and the whole team for inviting me. It's a pleasure to be in such an important meeting. The second year anniversary and the trajectory of growth is impressive. So really, congrats on your work. So as you can imagine from what I'm presenting today, I'm really passionate about serverless. It's one of the things that during my work here at AWS has really excited me, and I think it's showing us a little bit the direction where software development is going in the next years, and it's making some things so much easier to build and so much easier to manage after that. The idea of these presentations is really to plant a few seeds. So the idea is I will show you some of the things that you can do in terms of feature in the first part, and in the second part we will see actual customers. As we go through these features, we will, I think the idea is to see how these features can enable new use cases, and maybe they can simplify things that you're already doing. And as a common thread, I decided to go through a sample application. So, and let's say now that you have a new idea, you want to build something, let's say a web mobile application. How can you make it available as quickly as possible to your first customers that maybe will give you the first feedback to tell you, oh, this is great, or no, you're really doing something that is useless or boring or not applicable in this market segment. This is really important because sometimes especially startups, they waste too much time before releasing the first version. So having a fast development cycle at the beginning and as you go on is really important. So let's say that we want to build a mobile app. As an example, let's build an application that that you can use from a mobile phone. You upload your videos, hopefully not 1 hour and a half, as Chris was saying before. And then maybe the backend can analyze these images, these videos, and can extract some information, maybe the objects, the expression, the emotions that appear in this video. And then you can build maybe an intelligent index automatically to search for the segment in the video where something happens. To do so, now, of course, I'm proposing a serverless application because a serverless architecture, because this approach can help you build something that can scale easily and also can help you think of security as you build, because any component will somehow force you to think about which permission you should give and you shouldn't. So it's a good model to build something that can grow in terms of performance and security as you evolve it. So what I mean by serverless architecture. So with serverless computing, normally we use functions. On AWS, we have AWS Lambda. And when something happens, so for example, you receive an API call or a file has been uploaded or a database is being updated, this is an event. And this event execute a serverless function. That's your code, it's your business logic, has its own permissions in what this function can read and what this function can write, for example. And the platform is just managing the scaling for you. So it will, if many requests comes at the same time, it will scale up. And if there aren't requests, it will scale down so that you only pay exactly for what you use. And this function can do many things and can also call other functions directly or indirectly. And this chaining of functions can create very interesting event-driven architectures. And probably thinking event-driven is the big switch between a traditional application and a serverless application using this kind of approach. So in our case, our mobile video application, we can start by implementing the upload. We can upload the video. We can use a storage like Amazon S3, for example. This will trigger an event that goes into a function that will analyze this function. So the function receives the coordinates of the file. It has permission to read the file and will process the file. You can use maybe your own machine learning model, or you can use a platform that implements machine learning as a service. And it, as a result, it can write the outputs, for example, the objects inside this video into a database table. for example, a DynamoDB table or a relational database table if you prefer. Now that we have these results, we need to get this information from the mobile app. So the mobile app can use an API, for example, a REST API, or maybe you can, with an API gateway, or if you prefer, you can use GraphQL to get and ask for this information. This event will go to another Lambda function. And the fact that we have two separate Lambda functions here gives you an idea that we can keep the source code for each function relatively small, instead of having a large monolithic application, as it naturally happens when you add new features. So this get results function will have the permission only to read from the table. It doesn't need to write. We'll format the information maybe in some JSON format and send the result back to the client. And maybe your mobile app, you have the list of your uploaded videos with the description of which objects are there and at which time. And then you can, for example, index and search for when a dog appears in the frames of your video. When we build this kind of application, we have to think about the cost. As I said, now with serverless, you only pay for what you use. And in this case, now when you have highly interactive website or mobile apps, the functions normally are very fast, no? And maybe they return in less than 20 milliseconds. So in the past, until the end of last year, with the Lambda function, you would pay for the hundreds of milliseconds. So for the hundreds of milliseconds means that if you have a very fast function, you still pay for 100 milliseconds. Last year, we reduced this, increasing the granularity of the billing to 1 millisecond with no minimum duration. So if you have a function that lasts 2 milliseconds, you only pay for the 2 milliseconds of execution time. And since the cost and the free tier that you have with Lambda remains the same, it means that this is making things much more cheaper for many use cases. So for example, this is an application that I used to have before. The function were at around 27 milliseconds of execution time. I would pay 100 milliseconds. Now I pay 28 milliseconds with those of the rounding, and it's almost 1/4 the cost of what it used to be before, and it was already very cheap. Another problem is the processing power. So maybe I want to process high resolution videos. Now any smartphone or almost any smartphone can record 4K videos with high resolution. Do I have the power? Again, we increased more than 3 times the capacity of this is the size of the execution environment that each Lambda function can use. And then we can run multiple environments in parallel, but each environment now can be up to 10 gigabytes of memory. And the more memory, the more CPU you get. So you can have up to 6 virtual CPUs in each execution environment. And you can have 1 or thousands of those in parallel. This is making things much more interesting. It's just a flag that you change in the console or in the framework that you use to deploy your function. And one thing that you notice is that the power is nearly the same power you get from a modern laptop. So this is a customer that when we launched this feature told me on Twitter that they is using FFmpeg, and now the performance of Lambda with 10 gigabytes of memory and 6 virtual CPU is almost the same as the MacBook Pro that he just recently bought that is using an Intel processor, the 16-inch, and it was using, in fact, 6 cores. Of course, the more memory, the more cost. So one can say, okay, I'm increasing the memory, but if I increase too much memory, I get more CPU, then my application starts to be expensive. Actually, that's not always true, because you pay by the memory, but you also pay, as I said before, by the execution time. So if your function has more memory and more CPU and runs faster, then you have less duration and you pay less. And the two things seems to compensate very well if you have really good scalable code. So this is a test that I ran when we launched this feature. And I was using, in this case, a machine learning framework that is called PyTorch, that is very good at scaling and using all the available resources that you have. And this is a machine learning inference. So I was sending an image, and then it was trying to recognize the kind of bird that was in this image. And The orange bars that you see is the duration with different amounts of memory from 1 GB up on the left to 10 GB on the right. And the green line that you see is the cost. And as you see, the cost is not increasing much because I get more memory, more CPU, the function lasts less, and the two things compensate. Actually, if you do a quick check, you see that for 1 GB and 5 GB with this code, you have the same cost, but the function is 5 times faster to return. By the way, the cost that you see on the right, like the $60 cost, is for 1 million of invocations. So for processing 1 million of these images with these Lambda functions. And also, if you want to go a little bit faster, like 20% faster, you can decide to do so. And the sweet spot is 9 GB of memory. You pay 20% more, but it's 20%. It's 7 times faster. So I don't know, more than 40% faster. This is also a customer that ran his own test after we launched the feature, and as you can see again, you see the duration is the orange bar, and the purple bar is the cost. And again, increasing the memory, the duration goes down, and the cost always tend to be the same. So this is not true for every code, but if you already have Lambda function, I suggest you to do some tests. And there is also an open source tool that my colleague Alex Casarboni created that can do this comparison for you. It's called the Lambda Power Tool, I think. I can go back and say the correct name. And again, you can get as much power as you want to process these images, these videos, and but can you go faster? Actually, we're opening up the Lambda execution environment. And for example, now it supports some extension of the X86 instruction set, such as AVX2. And this is an instruction set that allows you to run instructions in parallel. So it's very efficient and very fast. And the good thing is that you don't need to actually know too much about it, because many libraries can help you use this by either enabling this support for AVX2 or by just switching the library for another one that does so. So, for example, a colleague of mine did some tests for processing images to generate smaller thumbnails using different algorithms. And the result was that with AVX2 enabled, it was saving 32 to 43% of the time. And as you said before, this is also directly saving on the cost, because you pay by the single millisecond now. And in this case, he was using the traditional image library that you use on Python, and he was just switching for one that has AVX2 enabled. So no change in the code, just a switch of library when you package the function. And again, no, in this case, I was showing you examples with machine learning or image processing. Often your Lambda functions require a lot of dependencies, libraries that you need to include. And normally with serverless platforms, you want to keep your functions small to have them start quickly. And there are also limits on how much you can send. To make this easier, we now support container images as a packaging format for Lambda functions. And this container image can be up to 10 GB. And the reason why we can do that is because internally we don't use containers. We use containers only as a format. So what happens is that when you upload your container image, we download and prepare this container image format as a fully downloaded storage, and then the Lambda function, when it starts, it's only downloading the bytes that it really needs for the startup. So maybe you don't need the whole 10 GB or the whole gigabyte immediately. You need it as the function starts. So the download is spread during the startup of the function, and the startup of the function is very fast, in line with what you would expect with a traditional zip file format function. So it's something that you can really test. And Using this is relatively easy. So if you're already using containers, it's not much of a difference with your traditional workflow. We provide some standard images that you can find on Docker Hub and also on our Elastic Container Registry. And then you can start from these images, depending on the runtime that you want to use, Node.js, Java, Python, for example. Then you copy your code, you can install your dependencies. So you can now run npm install or pip install on Python, for example. And then in the CMD parameter, in the command parameter of the Docker file, you can specify the handler. That is basically the name of the source file. App.js is the source file in this case, so on the name without the extension, and dot the name of the function inside the source file that that we should invoke when we receive the Lambda invocation. So it's super easy, and you can also override this at function configuration. That means that a single Docker file can contain multiple handlers, so a single container image can contain multiple functions, and you can just change the configuration to trigger the execution of one handler or another. And as I said before, one of the advantages of this kind of architecture is that you can keep your functions small, mostly single purpose, so the code base is easier to manage and update. But sometimes if you start to add features, even with this architecture, you start to have something that is too big, like a function that is doing the video resizing and then maybe is using machine learning. So how can you keep your source code small in this case? There's a way that I suggested is to decompose your large function into small tasks and then coordinate the execution of the tasks using a workflow. And on AWS, we have AWS step functions that can help you with that. And step functions now also supports synchronous express workflows. So traditional workflows with step functions can last up to 1 year. For example, an example of a long-lasting workflow is the delivery of a parcel to a customer. Something that in Amazon we know very well. So in that case, you may take a few days. So your workflow is not always running, but every time there is a step, it receives an input, it processes this input, and then goes into the next step of the workflow. With express workflows, you can have workflows that last up to 5 minutes, but they can be very fast and with very high scalability. And you can now invoke the workflow synchronously. That means that you can call the workflow and wait for the final result. And you can implement architectures like this that are described in this blog post by my colleague Ben, where you have an API gateway, so that is receiving an API with some text. And then you start a workflow where you have a first Lambda function. Is step 2 is detecting the sentiment of the text of the document, text document. In this case, it's using a machine learning service called Amazon Comprehend. Then it's generating a unique reference, it's recording the transaction on a DynamoDB table. And then based on the result of the sentiment, is this a positive sentiment or a negative sentiment? Maybe it's a customer feedback in this text. Then you can notify the administrator if it's bad, so that you using an email to take actions. Instead of having a single large function doing all of this, you can have 3 small functions when you see the small Lambda orange logo, and everything else can be managed directly by the step function workflow. Of course, building workflows is something new that you need to learn. For this reason, just recently, a couple of weeks ago, we launched the new Step Functions Workflow Studio, where you can graphically drag and drop the actions that you want to do, like execute this Lambda function, store this information in a DynamoDB table, send an email, and then you can drag the flow, like the choice state that you see here about at the center of the diagram, that depending on the output of the previous step can run for example, one branch or the other, or execute branches in parallel for increasing the speed. Each of these steps is getting an input state that is a JSON document and is sending in output an output state. And there are some internal ways of processing this state to make the functions work in a smoother way. So maybe the output of one function, you only need a subset of the JSON document to be passed to the next step. For this reason, we have some functions that can process this. And again, in the past, customer told us it's difficult to test this processing because you need to run the whole workflow. So now we introduced in the AWS console the data flow simulator, where you can put a sample state input and then you can test all the processing to see if it works as it is expected. And this makes much easier to manage the editing of the state as it passed through the workflow. More generally, in serverless applications, but also in any application, I would say there are two main integration patterns when you have a distributed architecture. One is message queues that on AWS you can use, for example, SQS, where you have a producer and a consumer, and you don't want to tie them together because maybe the speed of producing or consuming is different or can change over time. So you can put a message queue that will queue all the messages and serve the message to the consumer at its own speed. And then if you have a problem on the consumer, you can stop and queue messages and then reopen the queue when things are better. So this is a very nice architectural pattern when you have a distributed architecture. And we use Amazon SQS a lot in AWS and also in Amazon. Actually, just recently, we shared the results of the Amazon Prime Day. So Amazon Prime is this day that Amazon Retail is running, and Amazon Retail is using AWS. It's one of our customers, and they were using SQS with slightly less than 50 million messages per second at its peak. So just to give you an idea of how much SQS can scale up. And similarly, another integration technique is pub sub messaging. On AWS, you can do that with SNS. In this case, you create topics, and then you can publish information in a topic, and then the other components of your application that are interested in the information in a specific topic can subscribe only to the topics that they are interested to, and they receive this event and they can process the information. These are the two main architectural patterns for integration. Normally these systems like SQS, SNS are built to scale up, so that means that they don't preserve strict ordering on the messages, so you can receive the messages in a slightly different order than they were published. This is not always the case, but it can happen. For this reason, we have specific topics and queues that are built to process messages first in, first out. So FIFO topic and FIFO queues that you can use, for example, if you have a checkout processing for an e-commerce platform, and you want to process all the information for payment in strict order, and this is something that you can do, so that you're certain that the physical product, for example, is available when you reach the end of the checkout and another customer didn't jump the queue. Customer asked us to improve on this architecture. So a couple of years ago, or no, I think more now, because last year I almost didn't count. I think 3 years ago, we launched Amazon Event Bridge, that is a serverless event bus. And this is an extension of what we saw with this pub sub messaging. So instead of creating multiple topics and then subscribing to the different topics, with an event bus, you create a single event bus for multiple purposes, and then you can create rules. So all the applications that have a similar purpose, for example, all the systems relevant for the e-commerce platform publish their information on the same event bus, and then you can create rules that filter these messages and send the result to different destinations. So this is more flexible. So if you start to see that you have many topics to manage, then probably having a single event bus with rules, it's easier to manage and can create more flexibility as things get more complex. For example, one of our customers, Lego, and I will talk a little about them as a use case. They are moving many of their SNS topics into Event Bridge to simplify the integration of their components. one point that I missed at the beginning that is very important is that when you use these serverless functions, you can invoke them synchronously or asynchronously. So for example, if you receive an API call, you normally, the API gateway is invoking a function synchronously, waiting for the response, and then when it has the result or an error, is sending the result or the error back as the return of the API call. But many functions are actually invoked asynchronously. So for example, if you upload the video that you want to process on Amazon S3, this triggers the execution of a function to process the video, but this is asynchronous. There is no one waiting for the final result. So all these asynchronous events that generate execution of functions, normally they need to change some state. So normally, for example, the function maybe is writing the result on a database, otherwise their work would be lost. And also it's difficult to manage errors. We can retry, you can set how many retries, or for how much time we should retry a function in case there is an error. But how can you really monitor this? So to make this easier, we introduced 2 years ago Lambda destinations. And this is a really interesting way to integrate different components together, because that means that the return of your Lambda function, where you, for example, in JavaScript or in Python, is really the return statement of your Lambda function. This return statement can be passed to another Lambda function, or to a queue, or to a topic, or to an event pass, without you writing this integration code. So your function, for example, may read from SQS and write on Event Bridge. You don't need to use the AWS SDK. You don't need to know how this API calls the integration works. You just receive a JSON document from the input as the event. You process the information, and then you publish the result, and it's sent in your return statement, and is passed to the event bus. You just need to know the syntax that is expected in input and in output, but you don't need to use the AWS SDK at all. And this works also for errors. So it's really interesting. So normally you have an asynchronous invocation works like this. Now, for example, S3 is sending these events, a file has been uploaded or deleted, to an event queue. This event queue is sending the event as quickly as possible to a Lambda function that is executed and can do whatever they want. When you enable Lambda destination, you have two endpoints in case of success. For example, you send the result to SQS or Event Bridge. In case of an error, you send the result, for example, to an SQS queue that acts as your dead letter queue, where all the errors are kept and can be analyzed or maybe solved by reprocessing these events after. So all these integration bits that I was talking about are really can be confusing. There's many paths, many possibilities. So I created this table to give you an idea that this is not golden rule. It's not that this is the only way to do it. It works for most of the case. So the two main ways to integrate multiple components, and this works for Lambda function, but also for any distributed architectures, are orchestration or choreography. With orchestration, you have a central agent that is enforcing some behavior, like how you have to follow this workflow. With choreography, you don't have a central agent, but any component knows what to do. For example, with an event-driven architecture, every component knows which events they should listen to. And when they receive the event, they process the event, and they know which kind of events they can publish in output. And then all this input and output of events coordinates the multiple components together. So how to use this? How can you use this to approach? Actually, the difference is if you're using this inside or outside a single service or a single microservice. So inside a microservice or inside a single service, you have tight control on what you want to you can do, because you own the full service. So you can use synchronous or asynchronous invocation with step function, for example, and you can use the new Express workflow to process very quickly the content that is part of this workflow, similar to the example that I showed before when we were getting this text and we were analyzing the sentiment of the text and writing the result. Across microservices, you should always try to build asynchronous communication when possible. And in case of a workflow, that you can use an asynchronous workflow where all the steps are managed by the step function workflow, but you don't wait for the final result. The final result will change the state of something like in a database or in a storage. With choreography, inside the microservice, if you use serverless function, you can use Lambda destinations. That's probably the easiest way to integrate multiple component, multiple function inside and functions inside a single microservice. And you can do Lambda to Lambda, so send the output of one Lambda in input to another, or you can go through message queues or topics to coordinate more if you need to decouple or you have multiple listeners to a single event. Across different services, then the event bus approach is probably the best one. With Lambda destination, you can do that without writing any code. If you use other platforms, containers, for example, or you have a mixed architecture, you can use the AWS SDK to publish on the event bus and use this information to decouple and the different services. I think this makes things a little bit easier to see, and then I'm happy to get your feedback if you've used any of these tools. One point that is always very important when building application is security. And I see there's some questions in the chat. Since I'm sharing the screen, it's a little bit difficult for me to switch to one of the other, so I will take the questions at the end. So for security, we have many features, and one feature that we recently added that can really help regulated industry is the possibility to enable code signing. So you can really sign the code that you upload for your Lambda function, and then you can define different policies. So you can decide that in case a function, for example, in the test environment is executing code that has not been signed, you can just send a warn using a monitoring platform like CloudWatch. That can also send an email if you want with an alarm, or you can enforce the code signing. And so it's if you try to deploy something that has not been signed, it fails. So in this way, you can create a chain of trusted code from development to test and to production. And in general, if there's many security features with Lambda, this white paper that we updated at the beginning of this year can really be useful to see the many features that we implemented. One thing that I'd like to stress is that our serverless functions are not executed within containers, but are executed using inside a virtual machine. So because we don't trust container technology to share the execution for multiple customers. So the best approach is really that each function is running in their own isolated VM. We use technologies like KVM to and the resource capabilities of Linux to create this isolated environment. And we created this open source project that is called Firecracker to manage these micro VMs that are really minimized and can handle thousands of micro VMs on a single server, on a single host. And also the startup of this micro VM is very fast. And this is an open source project, and so if you're interested, you can find more information here. Is written in Rust, because we believe Rust is a great language. Its memory management makes it much more robust for, especially for low-level and system-level applications. And it's the same engine that is used by Lambda function, but also by Fargate. Fargate is the platform we use to run serverless containers, so containers that are executed without you having to manage the host platform, but just container itself is executed when you need it. Also, when you start to have such a granular architecture where you have different functions, different components, storage databases, it's much easier to apply at a granular level the principle of least privilege, where each module, each component only has the minimum set of permissions that it needs. It can only, like this function can only read from this path inside this S3 bucket. It can only write into this DynamoDB table, and this other function can only read from the same table. You can use tools like AWS Identity and Access Management to control these permissions, and you can really say allow or deny who can do what on a specific resource, and then you can add filtering conditions. So it's very granular. For new people coming to AWS, it can be a little bit not easy to digest at the beginning, because almost everywhere you go with AWS, you have the same model for permissions. But as soon as you get them, it's really a robust way to avoid giving too much permissions to any component of your architecture. For serverless application, managing a global state is also important. So storage is very important, and S3 is often being used for anything that doesn't fit well a database like images or text. And in the past, S3 has been seen like difficult to use for some use cases because it was famous because it was designed to be eventually consistent. Since it's a distributed application itself with many replications, when you were updating an object as a file on S3, you could still read the old version for a small amount of time. Now that's changed, and if you didn't notice, at the end of last year, now S3 offers full read after write consistency, so you can use it safely. And when you read from an S3 bucket, you always read the last. Easier.
I think we've lost him. Oh, and there we go.
Can you hear me?
There we go. There we go. Yeah,
sorry,
we just dropped out for a second there.
Oh, sorry, the network is terrible. So was it clear, my explanation of the full consistency of S3?
I guess you dropped out as soon as you kind of went to your last slide.
So this one?
Yeah.
Okay, so this is just a graphical example of how the full consistency in read and write of S3 now works. So if you write the same object from two different clients, and then you read the object from a different client, now you immediately read the latest version that you updated. And this is not easy to build with systems that work in a distributed architecture with many levels of replication. But now this is how S3 works naturally, so you can get the benefit of trusting that when you read from S3, you always get the last version. Also, with storage, we noticed that sometimes customers have their own data in an S3 bucket, and they want to share this information with different applications that have, for example, different level of security. And this is difficult because maybe you have an application storing some personal information, and maybe you want to analyze the data, but you want to share also that specific personal information with the other application because they have different levels of security. To make this easier, at the beginning of this year, we launched a new feature of S3 that is called S3 Object Lambda. And as the name suggests, the idea is that you still keep your traditional S3 interface, but as you download an object from S3, it can be processed by a Lambda function and changed, updated, or even created from scratch by the Lambda function. So to give you an example, let's say that you have an e-commerce application and you write maybe some information on the purchases of your customers in an S3 bucket. And this information contains maybe personal information, maybe the address of the customers. Now you have an analytics application that maybe is designed to work with S3. So you want to use the traditional S3 APIs and S3 SDKs, and you want to analyze this information, but you know that there's stuff that you want to remove. So in the past, customers normally were either creating a proxy, or they were duplicating the information, removing everything that the analytics application shouldn't see. And it was slow and costly because if you have 1 terabyte of analytics, you have to duplicate that for the different application that you want to analyze. So now you can use S3 Object Lambda to create a new what is called an access point. That it's an access point that speaks the same language as an S3 bucket, the same APIs. And then you can put in the middle a Lambda function that can do whatever you want. in this case is just redacting the personal identifiable information so that in output the analytics application is only seeing what it's supposed to do. And maybe you have another application like a marketing application that needs to know additional information. Maybe you have a customer loyalty database where you have loyalty information on your customer based on this classical loyalty cards that you get from almost any retailer. And in this case, you can introduce again another S3 Object Lambda access point. And you can have a Lambda function at this time is taking the information of the customer in the S3 file, and then it's doing a call to the customer loyalty database to enrich the information with maybe the loyalty level. Maybe this is a silver customer, this is a gold customer, and this has an impact for the marketing application. This platform is being used by customers for many different things. Just, I think today or yesterday, we published a blog post that is showing how Ryanair is using this to generate the COVID pass. So in this case, they have the information on the COVID status of the customer on an S3 bucket, and they need to generate the pass for the mobile app. So the mobile app is designed to integrate with S3, and they use S3 Object Lambda to transform the JSON information on the bucket into a PDF that then is sent to the mobile app. So for the mobile developers, it was business as usual. They use a privately protected S3 API, and then the generation is done by the Lambda function that is on the path. Moving away from storage, let's talk about databases. And DynamoDB is something that many customers use in these use cases, and it's low latency, scales very well. But if you're not familiar with NoSQL, it can be complex at the beginning. For this reason, I don't know, it's something we added at the end of last year. Maybe you read about it, but it's now also compatible with a SQL-like syntax. It's based on an open source project that we shared as AWS and Amazon that is called PartiQL. And that means that you can use SQL-like syntax. And there's also a free tool that we launched last year that is called the NoSQL Workbench that can help you design the data model for a NoSQL database and then test it and put it in production. So this is an example of what you can do. You can run SQL-like select all the music from this artist for this song. The question mark are the parameters, and then you can test it on a database that you have, and then you can generate the code for your application so that you can take the code and put it into your application. So it's much easier to start using DynamoDB. Also, when you design the data model, you can now import and export your data model using CloudFormation. That means that you can, CloudFormation is used to manage your infrastructure as code, so you can generate the CloudFormation syntax to generate the data model that you design. Or if you have a table that you want to import from another data model, you can use this feature to export and import the table into your data model and reuse it for another application. So this was, I think, a little bit of a flood of features and ideas. So let's see a couple of case studies that can put this into practice. So the first case study is Lego, as I pre-announced. It's a customer that I love since I was very young, and this has been developed in the UK, in London, in the office that they have in London. It's the e-commerce website of Lego, and when they started, this whole e-commerce platform was running on-premise in their corporate data center, and it was based on Oracle ATG. And this system was integrated with an SAP platform to manage the product catalog, the CRM, and also the taxation. And the taxation was integrated with a tax system. Again, everything was running on premises. When they start to use AWS a few years ago, they start to modernize this application, creating a new front end using Node.js and React. They introduce a secure gateway. The VPC that you see here is the virtual private network, is a sort of virtual networking that you can use to isolate and create virtual networks on AWS. And everything was working fine. Then in the Black Friday of 2017, what happened was that the tax system started to be slow. This slowness affected the SAP system, and then the slowness arrived to the customer, and then the tax system failed completely, and there was a cascading effect of everything. And at the peak of the traffic of the Black Friday, the e-commerce shop went down. This is never good by itself, but when you have this kind of problems, it's also the time where you can rethink your architectures. And one of the person that was part of this project is Shim Rizals, and he was participating to a few meetups here in London, the microservices meetups and the AWS meetups above all. And he heard of this thing called serverless, and he was thinking maybe we can use it here to solve some of our problems because of the scalability. And he noticed that the tax system, the same tax system that they were running on premises, was also offering a SaaS option, a software as a service option. And his idea was, let's integrate the software as a service option with our e-commerce platform, so that that can scale by externally to our data center. So to do this integration, the ATG is mostly a Java platform. He used an API gateway and a Lambda function. So super simple. The regular ATG was calling this REST API, and this REST API through a Lambda function was translating this to and from the tax system. He also introduced a feature flag, so the possibility of enabling this external integration or disabling, so that the taxation would go straight on. This is very important, especially for you can, like in the US, taxation is different for every state, so there's quite different rules. So that this tax system was very important to compute dynamically taxation for the e-commerce shop. So as you can imagine, since I'm talking about them, this was the beginning of their serverless journey, and things worked very well. So during the year, and then the next year with the Black Friday, they had a huge peak of sales, and everything worked. And actually, this was appreciated so much that the year after, in 2019, the full shop.lego.com was switched to serverless on AWS. And if you want to get more information about this, I got the pleasure of speaking together with Shim Rizals from Lego about the serverless journey in 2019. That's the first deck that you see here. And then this last year, in last December, we talk about the more advanced use cases that they are now implemented with serverless at lego.com. You can see the link to the slides and the video here. And I will share my deck with you at the end of this session. Another customer that I think is really interesting is in the media sector. So it's Sky, and this is Sky in Italy, my home country. And they wanted to share very quickly real-time sports updates with their customers. And this is the traditional problem, because normally content from the web is served through content delivery networks that cache the results, but real-time sports needs to be quickly updated. So they decided to rebuild everything using GraphQL, and use GraphQL subscription that are managed using AWS AppSync to send updates to what a customer wants to be updated depending on their configuration. So you can subscribe to different kinds of sports and get the updates for that sport. So this is the last picture of their overall architecture. It's quite complex. But there are two things that I want to highlight here. One is that they use this GraphQL platform using AppSync to send the real-time updates. Then there are, as you can see, a few Lambda functions, the orange Lambda that you see. And these Lambda functions are also taking the changes and synchronizes the changes that they come from these updates with the changes coming from the page editor that is using a traditional content management system that you see on the right. And these two words communicate using an elastic file system that is a shared file system that you can build on AWS. In this way, the content from the CMS and the content that is updated is written on a single file system, and then this is published as a static website. And since they have many updates, but they also publish everything as a static website. This is improving their search engine optimization and the level of search of how quickly people is finding them through a search engine. And the final result of this project was that they reduced costs by 30%. The data propagation using GraphQL subscription is very much faster than before, and also they improve the search engine optimization because they also keep a static version of the website for this, for example, robots that process your website, and they can keep it in sync. So what's the last question? How can I start being more serverless? Well, I suggest you have a look at these tools. So you have the AWS Amplify is a tool that can help you, especially if you're focused on front-end or mobile development. CDK is an open source project for managing infrastructure as code, and SAM is the serverless application module as a very nice CLI, especially if you want to start, and it's also integrated with the CDK. Our partners also have amazing platforms. I just pick and choose two of the most commons that I've seen customers using: the serverless framework, this is the one that Lego is using, for example, and also Terraform is the serverless coverage of by Terraform has improved a lot in the last years, and it's now quite interesting, and it's being used by many, especially enterprise customers, I would say. And how all these things can really help your idea grow. And yeah, I'm happy here to get your questions finally. And you can find me, as Chris said, as Danilo almost anywhere, and give me your feedback. Let me have a look at the chat. And yeah, Chris, if you're still there and you didn't fall asleep.
Yeah, I guess I mean, thank you very much for doing the talk. We've got a few questions in the chat. I guess we can start from the top and work our way down, I guess.
Yeah.
So first question's from Dan. And he was wondering about the differences between using a container image and a Lambda layer, and kind of what are the pros and cons of both of those?
Yeah, no, that's a huge question. So with the traditional packaging format with Lambda is a zip file. And then since many times there was something that was reused across multiple functions, traditional example is maybe your management framework or something like bound to security or some shared libraries, maybe that bring some binary that are always a pain to zip with a Lambda function, you would create a Lambda layer. This works, but still has the traditional limit of 250 megabyte of size. That's why we introduce container images. Container images solve two problems. One is if you're already into the container image tooling, maybe you use container images for checking security, antivirus, whatever, then releasing a container image is easier for you. And the other is the size, not 10 gigabytes, is much more than 250. So with container images, it doesn't make sense to integrate layers. But we have a solution to use layers with container images. So basically the idea is that, and we have a few examples of that. If you can ping me, I can show you the code. In a Docker file, you can import a Lambda layer as binaries that are copied inside the container images. So if you want to still use Lambda layers, either because you have functions using zip files and functions using container images, or either because just you like the idea of Lambda layers, you can still do that, and you can include them inside a Docker file with a couple of lines of code.
Cool. So I hope that answered your question, Dan.
Chris, can I just ask a follow-up question quickly?
Go for it. Yeah, absolutely.
Danilo, so does it affect the startup time, the size of the layer or the container image, as in, the cold start time?
Yeah, so with layers, what we do, layers are basically zip files themselves that we unzip into /opt in the environment, in the execution environment of the functions. And with layers, the order is important, because since the file system is the same, if you unzip one or the other, you can overwrite one file of the other. So when you add layers to a function, you have an order. I'm saying that because for performance, that means that we can unzip in parallel, but we need to go through the sequence because the second unzip can overwrite the files of the first one. So performance-wise, we do a sequential list of unzip. I think the maximum number is still 5 layers per function, but the more functions you have, the more unzip we have to do sequentially, and the slightly slower is the startup time. Of course, a single zip file or multiple zip files that add to the same sites, the time is not so different, but it's a little bit longer. With container images, we did something completely different. So we prepared the full image into something that we built internally, and then the execution environment is downloading the bytes with a lazy approach. So when the operating system starts and it starts to access the files inside the Lambda function, the bytes are downloaded. So if you have the size of the container image is not really so important now, because if you don't access bytes into this image, they don't slow you down at all. It's really how much bytes you need to read, and also of course on the runtime side, you can have some initializations that can be slow. That, for example, the old version of the Java SDK was pretty slow when you were creating new S3 objects. I mean the S3 handler and another service handler. So we rebuilt that. So my suggestion is container images are not slower unless you really read all the bytes before being able to serve the first function. So in that perspective, check if that makes sense. So sometimes it can make sense to do less initialization. So for example, you terminate the initialization of the Lambda function and then you continue to read stuff so that if you receive a request, then you can maybe have already the content there. So different strategies can help. More generally, there's some fine tuning that you can do, and one of the runtime that is more affected by cold start and latency is traditionally the Java and editing runs on a JVM, because the JVM is been designed for long living process. For that, there's some content that some colleagues of mine, including Mark Sales, that is based here in the UK, are doing to make it easier to use the Graal VM with Java. That is a VM that can produce a binary native format out of the Java bytecode. So if that can really speed up the startup time for Java. And there are similar solutions also for other runtimes.
Okay. Thanks very much.
Cool. Okay, so next question is from Chris. So what is the easiest way to minimize vendor lock-in with Lambda functions? For example, in GCP Cloud Functions, you don't need to import any Google libraries for Go functions. You can just deploy it as it is.
Yeah, we are actually looking at how to make things easier in general. So that's definitely something we're looking at. And the example with Go, it definitely fits into this. So expect medium long term that we will try to get closer to making things easier so that you use your traditional approach. But more in the short term, what I suggest is, so first of all, if the whole problem of lock-in is always put into the wrong perspective, because most often the problems when you need to move stuff from one environment to another is not the compute part. It's the storage, it's the databases, it's the network configuration, the security configuration. That's the most complex part, and there's no easy solution for that, I would say. If you want to increase portability, container format definitely helps. You can also create container images that can run on Lambda and on a container platform, because you just need to change the wrapper there. You can create a wrapper for Lambda that talks with the Lambda runtime and a wrapper for a traditional web server. And when you build this wrapper once for a runtime, you can use it for all the containers that you have. So that's something that I've seen being used, and it's something that maybe you can evaluate. And so, in that perspective, probably container images are inherently more portable than zip files.
Cool. Yeah. Again, Chris, feel free to unmute yourself if you want us. Yeah. So next question again from Chris. So he says, what are the best practices around finding the point where it's cheaper to run always on compute this Lambda function ahead of time?
So first of all, many customers use Lambda not for pure cost on the compute platform, but because it's faster for them to develop, it's faster to update and the business logic because of the nice decomposition that you get. So in that perspective, the pure price performance of the compute platform is not the most important parameter in my opinion. But if you focus on that, then it's really math. So you should just look at the average execution time of your functions and at the different options. So using, for example, Fargate or hosting containers on another platform, and do some math. It's a spreadsheet. We can help you with that. Now, if you have an AWS account team, but I can help you if you're doing something and double check if you're not missing something. But it's just pure multiplications. Normally, it depends really on how spiky is your workload, and also how critical is for you to cover the peaks. Now, in case if you're a startup, for example, and you have everything stable, but then someone writes about your company and you get a huge peak of requests all at once, you don't want to miss those requests, because if you fail there, then probably you compromise now the whole experience. And similarly, if you're launching a new platform for an enterprise, you want to be ready for these peaks, and Lambda can really make it easier than with traditional platform. So if you have this kind of peaks, probably the cost benefit is different.
Oh, that's super useful. Thank you.
Cool. Okay, next question is from Dan. So does the data flow simulator have an API, and could it be used as part of a CI process?
So it doesn't have an API. It's designed to be more of a graphical interface as you design. If you do that as part of a CI process, I would probably go with the execution of a workflow, so a state machine execution, because you reproduce exactly what you want to test, and it should be part of your either unit test or integration test. So I would probably go that way, but I'm curious to see how you would see that part of CI. So if you want to maybe send me a quick note, I can have a look and then maybe check with the step functions product managers to see if it can make sense. Because for now, I would just go with the execution of a state machine in a CI environment.
Cool. Okay, and then last question is from Dan. So how is destinations different to a dead letter queue?
Yeah, that's a very good question. So I didn't cover that in the slides because it was already so much information. So it's two different features, and today I would use destinations over the DLQ. So in the past, to solve this problem of monitoring errors for asynchronous execution of Lambda functions, we introduced this specific feature that is the dead letter queue. That means that if there's an error, the error is sent to the dead letter queue. But it was covering only errors and not success. And and it was a little bit limited. So when we introduce destinations, our idea is to completely replace DLQ. The feature is there. If you already use them, you can safely continue to use them. But for new projects, probably I would use destinations. If you think destination is missing something that you do with DLQ, it shouldn't be the case. Let us know, but there should be feature parity plus the other things that destinations offer.
Cool. Does that answer your question, Dan?
Yeah, great, thanks. So just to jump back to the data flow simulator and kind of CI question, it was mainly because we were doing something with step functions a little while ago, and we did find it kind of difficult during like the CI process in testing. So because we're kind of unit testing each Lambda function, but then it's like, you know, how do you then kind of test a bunch in succession? You know, from state to state. So I think I kind of got the idea from your example in the data flow simulator part, where you know, you could chuck an event at it and it would run through you know, as much as I guess as it could. So it kind of just popped into my head at the time. This sounds like a good thing for part of maybe not CI, but maybe end-to-end testing sort of thing. Where you could do it out of the console and just let it be part of the process.
Yeah. So as I said, if there are other problems that I don't see, I would suggest to run this into a test account. So where you reproduce the resources of your production account and in a smaller scale, but with serverless normally you don't need to do that, and run that. So you unit test all the functions, and then you run in a second step the full workflow on the real platform. Cost-wise, it shouldn't be an issue, and you're really testing the exact same thing. There are emulators with step functions, so you can possibly use emulators, but personally, I would not do that, because local testing is something that we started to do because production environments were too expensive. Now it's not the case. So for me, I would set up that into a test account. But again, if I'm missing something and you want to catch up, let me know, because that's definitely something, if we can improve the developer experience, that we can help. The data flow is really seen as something you do in the console while you develop to create the right configuration for your development.
Yeah. Okay, thank you.
Cool. Is there any more questions from anyone on the call then? Feel free to unmute yourself if you did have a question. No. Cool. All right then. I guess I can steal the screen off you. Big thank you, Danilo. That was an excellent talk. It was really, really interesting, that. So if I just take this, just to kind of wrap up for the evening. Yeah, so if you have any feedback for Danilo or any of the NETech team, please do just get in touch. As you mentioned, you know, he's all of the major social media platforms, as Danilo is pretty much everywhere. Any feedback, you know, we really appreciate it. Or if you have any further questions and you know, think of anything after the Meetup ends, you know, please do get in touch. So yeah, if you want to get in touch with any of the NETech team, those are the kind of social media handles there. As I said, the easiest place is if you go to any.technology and go to the contact us page, and you can find all of the links there. Please do check us out on the YouTube channel. You know, we'd really appreciate if you do the whole like, subscribe, the full thing. Yeah, you'll get all the latest from there. So all that's left to say is just, you know, massive thank you to Danilo and everybody else on the call. You know, I'm so happy to kind of see NETech kind of get to where we are now, you know, nearing 1,000 members, and yeah, 2 years in. And I really hope, you know, that, you know, Danilo, you can come back and do a talk again, because that was really, really interesting. And yeah, we hope to see everybody next month. So thank you all, and enjoy your evening.
Thank you.